My name is Fatima Azara, so I'm gonna explain about the introduction. So what is a volumetric analysis? So volumetric analysis is a method that used to determine the concentrations of a solution. So how does it work? So it works by measure how much of a solutions with a known concentration needed to fully react with another solution. So it relies on the principle that chemical react in preheats, which is next I'm gonna explain about the calcium carbonate. So calcium carbonate is an important mineral that mainly appears as sulfide, which forms a clear and hexagonal crystal. So calcium carbonate is an important mineral that mainly appears as sulfide, which form a clear and hexagonal crystal. So it's make up marble type of crystallized calcium carbonate and limestone, which is a rock mostly made of it. So calcium carbonate is also found in pearls, corals, and also seashells. Another form of calcium carbonate is aragonite, which has a different crystal structure from poly-90. I'm going to explain about back titration. So back titration is an analyte concentration that found by reacting it with a known quantity of excess reagent in a titration technique, call it as a back titration. So after that, another reagent is used to titrate the remaining excess reagent. So it is possible to determine the original analyte concentration, since the second titration's result indicates how much an excess reagent was utilized in the first titration.
Let's move to the theory. First one is titration principle. Titration principle is a process which starts with standard reagent of known concentration from the rate, and then titration principle added to solution contain analyte until reaction between analyte and reagent is judged to be complete. The second one is equivalence point. Equivalent points is a point which reaction is complete, and then stoichiometric amount of titrate is added to analyte. So for the third one is indicator. Indicator give color change at or near equivalence point, and then indicator can add to reaction fast to give signal when all of analyte has reacted. Then the last one is type of titration. There are 4 types of titration. First one is acid-base titration. Second one is complezometric titration. The third one is precipitation titration, and the last one is redox titration. Now let's move to the methodologies. First step is 1 gram of each of the sample was weighed on weighing balance and put into the conical flask by adding several drops of ethanol, which act as weighting agent and helps the HCl dissolve the calcium carbonate CaCO3. Second, 10 ml of 1 m HCl solution was measured in measuring cylinder, which is 10 ml of measuring cylinder, into each flask and swirl the flask to weigh the solid. Third one is the solution in the flask were heated until they begin to boil and were allowed to cool at room temperature for complete dissolution. Next, 3 drops of phenolphthalein was added to each flask using a funnel, and clean burette was partly rinsed. For the next step is the burette was again filled with NaOH solution and run some solution out to remove all of the bubbles from the tip. The initial volume was recorded as 0.01 ml. Next is the first sample was titrated against NaOH to the first persistent pink color. When it was close to an endpoint, the color faded slowly and the remaining NaOH was added dropwise until the caloriment for some seconds where the final volume was recorded. And the last one is titration for other samples where was repeated, and the percentage of calcium carbonate in each shell was calculated.
As for the result, the study comparative analysis of calcium carbonate contained in Eggshell involved titration method of analysis, and 1 gram of each of 4 samples were used in preparing the aliquot. Now let's look at the chemical equation, which is we have CaCO3 plus 2HCl as the reactant and CaCl2 plus H2O plus CO2 as the product. Now for the next chemical equation, we have NaOH plus HCl as the reactant, and we will get NaCl plus H2O as the product. Therefore, the initial moles of HCl is equal to volume Cl times molarity of HCl is equal to 0.01 liter times 1.00 mole per liter. We will get 0.01. Now to get the moles of HCl left, which is equal to volume of NaOH times molarity of NaOH, which is equal to 0.00222 times 0.100 mole per liter. We will get 0.00022. Next, we have to find the moles of CaCO3, which is equal to moles of HCl reacted times 1 mole of CaCO3 over 2 mole of HCl. First, we need to find the moles of HCl reacted, which is equal to 0.010 minus 0.00022, which is we will get 0.00978 mole. Next, we can find the moles of CaCO3, which is equal to 0.00978 times 1 over 2, and we will get 0.00489. Therefore, we can calculate the percentage of CaCO3, which is equal to 0.00489 times 100 over 1 over 0.50 times 100, and we will get 97.8%.
So in the conclusions, the first objective that we acknowledge about volumetric analysis, or known as a titration analysis. So the purpose is to determine the solutions of concentrations. The method is measure volume of known solution, which is titrant, react with analyte. The reaction is based on fixed stoichiometry ratios, and the equivalent point is when titrant fully reacts with analyte. So for the second objective is a theory behind a volumetric analysis. So we know that volumetric analysis involves adding a titrant of known concentration to an analyte until the equivalence point is reached, where their molar amounts are stoichiometry equal with an indicator signaling the add point, and can be performed in a various type such as acid-base, redox, complexometric, and precipitation titrations.